walk you through a demonstration on a program I put together for Sci4. Sci4 is a program sponsored by NYU Poly and the ISIS Lab, and it's a free online forensic learning environment with a target audience of high school students from around the country, but participants from anywhere. The website for Sci4 is sci4.isis.poly.edu. So I'm going to take you through what I put together. It's host and network forensic correlation. I'll skip through the slide work quickly. It's attached if you want to take a view at it. But essentially trying to combine host-based forensics and network-based forensics into a common set of artifacts for analysis. So the premise is take IDS alerts and host forensic data and try to mash them together. Minimum success, start with the packet capture and a host image file. Find modifications and try to correlate some of the events. There's a lot of expansion ideas as I started down this path. There was more and more that I wanted to do. It could be doing more with the event logs, doing more with the registry logs, doing more with net flow data. There's a lot more that could be done. This is really just the tip of the iceberg. But I think the combination of host and forensic data together at the same time is something that's not utilized too often. So the scenario, again, 2 inputs, network traffic in the form of a PCAP, we'll take a look at that, and then host data in a raw image file. So the scenario, I attacked a vulnerable host. First I scanned a vulnerable host with Nessus and Nmap, identified an exploit, launched an interpreter shell, and then had some fun. So I dropped some exes, some pictures, some other things, did some time stomping to see how that would affect things. So the data, the scenario plays out. Outputs, network artifacts, host forensic data, and then the correlated event data is a single database with the forensic data inside of it. So enough with the PowerPoint. Let's go take a look. So there's the Python script. You can pass the arguments through the initial command line, or you can enter them. I'll enter them one by one. So the first one is a image file. So there it is. It's a Windows XP image. Then I'll enter the packet capture. So this is meg packet capture for the period of time while it was under attack. One of the IDS that I used is Snort. So the Snort has a rather extensive set of rules that come with a free subscription. So that was my choice. There's Bro and some others that are becoming popular as well. Snort has a pretty large config file, so getting Snort installed and running on my Mac was one of the first things to tackle. So this is mostly the out-of-the-box config. There was also some help files that I referenced in the PowerPoint presentation that really talked you through how to configure that on a Mac. So path where all my Snort logs are written, so one of the settings I had in my output was to write to a CSV in addition to the standard syslog output. So that's the CSV. So this should be the last argument. Now it's asking me if my disk is a partition or a full disk image. In my case it is a partition. It was a VMDK that I then converted. Let's go ahead and hit P. And there's the work. So it's going to scroll by pretty quickly. As you can see, it already ran through most of the host data. So again, there's more and more that could be done. On the screen, it's running through the packets. That's the snort replaying the PCAP. While it's doing that, scheduled logs, so task scheduler service, um, event logs, application security system, the full MFT. So for those of you that aren't aware of what the MFT is, it's the master file table. So all changes, all modifications, everything that ever goes on the disk is all recorded here. So that's that. On the network side, I have some left over from my previous run. I apologize. I output everything that came out in standard out, so it does the default snort interface tells you a lot about the preprocessor settings, the SSL settings, what types of packets you're seeing. I left that in for, I logged it, wrote it out to a file, so it's available. The snort alerts is really the file that shows the network alerts. So again, this is converted to a CSV, and this is any of the alerts that triggered rules that were configured. So there's some here that were my attack. So the final artifact is a database. So I mentioned before the database with all of the data kind of munched together available in it. So there's some more work that I would have liked to have done here if I had a little bit more time. Some normalization and some better correlation. For now, it's a couple of tables in a database, which at least gets all of this into one place, queryable and actionable. It'd be easy enough to dump out to a CSV or something else if you prefer to work on a flat file. So that's it. Again, lots of room for expansion in terms of just taking this further with all the event logs, with all the the master file table. There's a lot of timelining that's being done, and I think it's a great way to look at some of these attacks. And hopefully, my concept of contributing the network data on top of that traditional host forensic data resonates and adds some value. Thanks for listening.